Hello and welcome. In the previous lab, you containerized an application and shared it on Docker Hub. In this lab, you will learn how to change the behavior of a container by passing arguments to it. Let's get started. Reminder: please do the labs in sequence as they build on top of each other. Let's start by taking a look at the entry point Docker instruction and the CMD Docker instruction. You can find references to these Docker instructions under the resources attached to this lab. Let's now take a look at how they are used in the Fibonacci application. You already pulled the code for the Fibonacci application from Docker Hub in a previous lab. If you are using Windows Subsystem for Linux terminal under Windows, type explorer.exe space dot and press enter to launch the current directory in the Windows File Explorer. Use your favorite editor or IDE to open the Fibonacci sample on your machine. I suggest using the free Visual Studio Code. An entry point instruction allows you to configure a container that will run as an executable. You specify the executable and command line arguments, and this becomes the full command that the container will run when it starts. Here, the command for the backend container is python 3 -u/scripts/api.py. Let's now look at the CMD instruction. When used in combination with the entry point instruction, the CMD appends default parameters to the container's command. If we uncomment the CMD instruction at line 12, the command for the backend container becomes python 3 -u/scripts/api.py -v3.o-l true. Go ahead and uncomment line 12 and save the changes. You can find a PDF file with the full list of the commands you will run under the resources attached to this lab. Please download this PDF now and keep it handy to help you with typing the commands for this lab. Let's build the Docker image for the Fibonacci backend after the changes we made to the Docker file. Go back to your terminal. Make sure you are in the directory Fibonacci sample/Fibonacci backend. Run this command to build the image with the new changes to the Docker file. Notice how Docker build command finished much quicker this time. This is because Docker did not build all layers in the Docker file again. It made use of layers cached locally, which did not change. Then it just added the change from the line that we uncommented. Open the REST API from the previous lab using this link from a browser on your Docker host. Note the application version printed as Fibonacci version 1.0. This is because the default value for version is set to v1.0 in the api.py file at line 11. The version can be changed by passing an argument to the application. See how arguments are parsed in api.py file in the function parseParams starting at line 65. Now let's run a new container that will print version 2.0 as the version. We will expose this container on host port 30056. Simply run this command. Remember the entry point and the CMD instructions from the Docker file? The arguments we pass in this command will replace the default arguments from the CMD instruction. Therefore, the container command becomes python 3-u/scripts/api.py -v v2.o, which instructs the REST API to print a version of v2.o. If you invoke the new container serving at host port 30056, you will see the app version printed as Fibonacci v2.o. Notice how easy it is to run different versions of the container. Change the port and you get a different version. We will run one more variation of the application shortly. Run a new container and expose it on host port 30057. Do not specify any additional arguments. Now, the default values from the CMD instruction takes effect. The -l true argument instructs the REST API to save function invocations to a log file. Check the new container in the browser. We get internal server error. Why is that? Let's inspect the container logs. Copy the first few numbers from the container ID and type the docker logs command and pass the ID. Why did we get that file not found error? Check the REST API implementation in api.py. Look at line 63. The log file defaults to /logs/system.log, but there is no /logs directory on the container to begin with. We will solve this problem by defining a container volume. It is common practice to persist data on the host file system in order to preserve state in case the container crashes. We can always start a new container and make it mount the same directory on the host machine as a volume. Here, we would like log messages from the Fibonacci function invocations to be persisted on the host machine. Create the target directory on your Docker host. On my machine, I created a directory at /mnt/c/fibonacci/logs, which maps to a directory under the C drive on a Windows machine. Mount a Docker volume that points to that directory. Run the following command to create the container with the volume. We will expose this container at port 30058. The directory on the host will be mapped to the directory /logs on the container. Let's test in the browser. It works this time. We should see logs written to a system.out file on the host machine path. Check contents of that file. The logs are indeed there. That's it for this lab. You have learned about ENTRYPOINT and CMD Docker instructions, changed the behavior of a container by passing arguments to it, created a Docker volume that maps to a directory on the Docker host, and ran several versions of the REST API server simultaneously.